Welcome back. This is the third lesson recording for IM1, September 15th, 2020. So lesson recording B is actually where I'm spending time going through the homework, last two homework really thoroughly. So I am just going to show you the answers here. When you see it, I want you to make revisions. If there are any questions that are wrong, mark it with a red pen so that you know that what you need to be watching out for. Make sure you are drawing in boundary box for the graph to help you. That's really helpful. Check the smallest and the largest values are correct. And check that you have x and y in your inequality, x for domain, y for range, and that the direction of the inequality is correct. It should be always opening to the right. And if you're feeling confident, you can go on to the challenge problems on Desmos. Those are the cards number, I think 2 to 5 or something like that. It gives you a title at the top. Okay, so, here we go. So this is the homework that was due today. Again, I did the same thing what we did in Desmos. I drew the boundaries and then I shaded it in, and the answers for domain and range are here. And that's for the second part. The graph should look like that, increasing and then decreasing, increasing and then decreasing, and then finally increasing again for a little bit. The domain is all real numbers between -2 to 4, and check out all the inequalities and how it is written. And these are the answers to the homework that was due previous lesson. You can pause the video and check the answer. Okay, so let's continue with the lesson and let's do some more domain and range practice. So when I see a graph, I want to draw a rectangle that encloses the whole graph. Okay, so then I can start drawing from here. And then I can go across here. And then I can draw okay, so my rectangle will look like this that encloses the whole graph. Then it's easy for me to see where the minimum x value is. This will be 1 here, and 4 will be the other x value. Okay, so I know that domain is all real numbers between +1 and 4. And how do I write that in inequality? The smaller number is on the left, the larger number is on the right, and we're talking about domain, so the x is in the middle and the inequality opens to the right, like so. Okay, then range. What about range? Range, we're talking about the y value, right? But now this rectangle does not include the y-axis. Is that a problem? Not really. We just need to extend it. Oops. Like so. And then the value here is what? -3 is my minimum value. And then for the y value is +3. Okay, so then the range is numbers between -3 and +3. That will be in English. Using inequality, it will be -3 is the smaller number, 3 is the bigger number, we're talking about range, so it's going to be y, and inequality opening to the right, like so. Okay. Okay, with this problem again, I am going to draw my rectangle. Okay, let's do another example here. We want to draw a box to enclose the graph completely, like so. And then maybe okay, there we go. All right, so this tells me the domain will be the x-axis. Remember dogs and ray. So I'm just going to do the inequality notation. It goes from -2 to +4. So -2 to +4. We're talking about domain. So it's going to be opening to the right. Okay. And then range, we're talking about the y-axis values. What's the minimum y value? It's 0, right? What's the maximum y value? It's +2. The smaller number is 0. The bigger number is 2. And we're talking about range. So that's a y. And so we're going to use the inequality that is opening to the right, like so. Okay, so this is the range. And this is the domain. Okay. One last example. So again, I am going to draw a line, a box to enclose the graph. Okay, and then okay, that's my box. Now I can say, okay, the domain is the x values. So go to the x-axis. What's the minimal number the graph extends? It's -2 here. So -2 is the smallest number. What's the biggest number? It's +4. +4, and we're talking about domain. So it's going to be x in the middle, like so, and inequality opening to the right. And what about range? Okay, range is the y-axis, because ray tells us that range is about the all possible y value, and the minimal value is a little over 1, 2, 3, little over negative. Oh no, this is okay. This is 2 here, so this is 1 here. So this is 1.5. So maybe 1.7. So -1.7. And the biggest number is probably about +1.7. And we're talking about range, so it's the y in the middle. Inequality opening to the right. Great. Okay, to save time, I went ahead and drew the box on this graph now. Now let's talk about domain. Domain is the x value. That means we go to the x-axis, find the minimum value and the maximum value. The minimum value is -2. The maximum is +2. So minimum is -2. The maximum is +2. And we're talking about x in the middle because we're talking about domain. The range is, what's the minimum value? It is about here. So that's, okay, that's 1. That's 0.2, 0.4, 0.6, 0.8. So this is -0.4. Okay, and then what's the maximum? If this is 2, 2.2, 2.4, 2.4 is the maximum, and we're opening to the right as usual. Okay, let's give some announcements. So again, there will be your unit test. Next class will be on and the topics are on the quiz 1 and 2 material topics, the function machine, function notation, the function domain and range from graph. And something you should realize is that there are no retakes for tests. That means you need to prepare accordingly. This is it. And for homework, you are going to do a review packet. I am going to say you need to spend at least 45 minutes. Okay, that this part required, part optional, that's not quite true. So you need to spend at least 45 minutes, and please realize that the more time you spend, more effort you put in, the better you will do on the test. And also you should not just go on to the questions that you can solve. You should actually prioritize the questions that you're not sure about, so that make sure that you know how to solve them. I am going to put my solution, worked out solution, and the answers on the same page in the module as the homework, okay, as the review packet, so that, and that's going to happen tomorrow on Wednesday. I want to give you guys a chance to do it yourself before you just go on to the answers. And please make sure that your answers are correct, not just do it, but you need to make sure that you are doing it correctly. So please make sure that you are doing, check your answers against it. I will hold extra office hours on Wednesday morning and afternoon. So that's tomorrow morning and afternoon. After you are done with your outreach class, then you can come over if you need any help or if you have any questions, or just simply to work on the review packet together. I welcome that. So please come. I am getting some students joining me to do homework together on the B-Day study hall at 2:15, and that's a lot of fun. Okay, so this afternoon at 2:15 we are going to get started with the homework review packet. So please join us, and it will be easier that way. And also, last day to submit your any late homework is end of day on Wednesday. All right, so okay, so the function machine. Now the question comes down to, is this a function or not a function? We've already talked about this. So remember, we said that it is a function. For a machine to be a function, its output must always be predictable for any given input. That means you need to have same output for specific input. So is the one on the left a function? Well, why or why not? Well, look at the 1. Well, I see a repeating input here, 1 and 1, but when you put in input for 1, it gives 5, and then you do that again, it also gives 5 again. So in this essence, every time you put in 1, it's always going to give 5. So 1 gives 5, 1 gives 5. If you put in the input of 2, it will give 4, and do it again, it will also give 4. So is this a function? So the input always gives the output of 5, the input of 2 always gives the output of 4. That means the output is predictable for any given input. So therefore, this is a function. In contrast, let's look at the next machine. Machine B, what does it do? When you put in number 1, you get 5. But sometimes when you put in 1 again, sometimes you get 4. Same thing with 2. Sometimes you get 5, sometimes you get 4 as when you put in the input of 2. That means the input of 1 sometimes gives 5 and sometimes gives 4, and input of 2 sometimes gives 5, sometimes gives 4 also. So the output is not predictable for any given input. So in this case, this is not a function. Okay? Alright, so I'm going to stop it there.